Now, the diagram shows a rectangular frame ABCD with a diagonal brace DB. Prove that the triangle ABD and DCB are congruent. What you first do is you identify your two triangles that you're using. So you might almost have a slightly you'd almost have a slight this imprinted in your head that you're doing this triangle here versus this triangle. Well, sorry, opposite colour. You're doing that triangle there versus this triangle here. Are you alright with that? Okay, yeah. Yellow versus grey. Sorry, yellow versus blue. Right. Next thing you do is you write down both triangles. You write down you write down triangle ABD here, and then you write triangle DCB here. When you see the word congruent, without even doing any work, you just write down your list. Where it says in your test, prove it's congruent, doesn't matter which one it is. If you have one of these down and the answer involves one of them, you've got marks on the board. You can specify at the end of the question which one it is, but just have them all there just in case. Okay? That's it, marks are already on the board. Now, which one I'm going to do? It specifies that it's a rectangular frame. Would you agree with that? Yeah. So I would argue that DC is the same length as AB. You put down a reason as well. What would the reason be? Opposite sides of a rectangle. Okay, then I'd say that look, DB, which is the centre one, is the same thing as DB. It's a common side. Would you agree with that? Yeah. DB is the central line. It's in both triangles. So DB equals DB. Then finally, what's the last side? AD equals CB or BC, whichever one you choose. What's the reason? Opposite sides in a parallel, in a rectangle. And you just write down SSS, and then you say the triangles are congruent. Another person comes along and does it a completely different way. We can do this several different ways. Okay, another person does it this way. He just rubs out the top part altogether. He rubs out the top part here. He decides to rename DB what? The hypotenuse. He then decides to label this angle here the angle DAB. What would the other angle be on this one? The other right angle triangle in the yellow one equals DCB. And you say 90 degrees. Person B has proved they're congruent. Sorry, Paddy. Person B has proved they're congruent by RHS. Another person comes along, and instead of doing either of them, what this third person does is something like this. Remember I mentioned the CX factor? That is corresponding angles are the same. This is where the opposite angles are the same. This is alternate angles are the same. The third person comes along and does it a completely different way again. What they did is this. They said this red angle here equals red angle there. How do I write that down? Angle ADB. Would everybody agree with that? A to D to B equals angle D to B to C, or C to B to D. Doesn't matter which one you do. D, B, C. It then comes along and goes blue angle equals blue angle. What's the reason? Alternate angles, the Z and the N. Look, see the way it's like a Z and an N. Okay? The other person comes across and you write down your reasons, alternate angles, and what does this second person say? He says angle DBA equals CDB. Okay? That's an angle, that's an angle. What do I need in between them? What side do I have to use? the one that links both of them. And then I say D to B equals D to B ASA. That's the reason it's congruent. Can everybody see that? Like, you may have a completely different answer to me, but you can do it 3 or 4 different ways, this question. Okay? Move on to another one. Something with a bit more difficulty. Okay, question 20, part 1. What does it want me to do? It wants me to show that PR, please pay attention to this part. This part is telling you how to do everything here. What does PR equals QS mean? It means it wants me to show that P to R is the same length as Q to S. That's a roundabout way of asking me, it's a roundabout way of me saying, why don't you prove that the blue triangle is the same thing as the green triangle? That's what's basically asking me. If I prove they're congruent, if I prove they're exactly the same, then I can relate the information back to proving that PR equals QS. So just let's go about proving this. What's to tell me in the question? What information does it give me below it that might help? It gives me a PQ equals QT. So I'm going to write down both triangles. Okay. What's the first triangle I'm working on? RP. Q. The second triangle I'm working on? QST. Now, what's the first piece of information they've given me? They tell me that PQ equals QT. What's the reason? It's given. That's an S, right out the bats, yeah? Now, what does it also tell me? It tells me that PR is parallel to QS. What would that mean then? PR is parallel to QS. What does that mean about those two angles? Huh? They're the same, aren't they? So I can write down angle RPQ equals angle, was it? TQS. Reason parallel lines. They're parallel, coming from the same baseline. Okay. Does that give me anything else then? Can I prove that? Can I prove that this angle is the same as this angle?
Yeah, it says.
How?
It says RQ is parallel to ST.
RQ is also parallel to ST. So I'm going to have I think I'm going to have an ASA here, am I?
Yeah.
So it's triangle, angle what is it? RQ P is equal to the angle STQ. And the reason being, they're parallel. What do I have here, guys? Look at it here. I have A, S, A. Angle, side, angle. Angle, side, angle. ASA looks something like this, guys. It's that one, that one, that one. And you know that these two angles are the same. And you know that the side in between is the same. So we have angle, side, angle. So we're proving that they are congruent. ASA triangles are congruent. What can you say then, guys? Revert it back to the whole thing. PR equals, they're corresponding sides, aren't they? If that's the black angle, that's the black angle. That's the red angle, that's the red angle. Then just think of a third colour. Purple angle, purple angle. The line, keep focused, the line P going to R is in between the black and the purple angle. The line Q going to S is in between the black and the purple angle. Therefore they are known as corresponding sides. Means they're the same sides. That okay? Corresponding sides. How much time do I have? 4 minutes. Okay. Last one. this signal here means they're congruent. Everybody happy enough with that? So, I'm just going to fill out this right away. You give me the reason why. Why is this red angle equal to that red angle? Fairly the opposite. Why is this blue angle equal to that blue angle? Huh?
Alternate angles.
Alternate angles. Why is that green angle equal to that green angle? Okay. So, and it also tells us that this part here is the same as that part there. So basically, if I will, I'll just highlight it. This yellow line is the same length as that blue line. It gives it to us, doesn't it? I have ASA right away there, don't I? Just a matter of writing it down, doesn't it? The angle, the blue angle, which is QPR, is the same as RT S. The red angles are the same. The angle SRT equals PRQ. The length P to R is the same length as R to T. ASA, they are identical triangles. Okay, guys. For